Okay, starting a brand new unit, Unit 6, Functions. We're going to do a lot of Desmos activities in this topic, as well as doing a lot of visuals. There's definitely a good visual component with the topic of functions. So this lesson, lesson 48, is an introduction to functions. Just to start us off, some definitions. A relation is a set of ordered pairs or two objects that go together. So you've probably seen a set of ordered pairs before, something basic like 1, 2, and then like there's another point, maybe like 3, 4. Just things that go together, two objects that go together. And then a function is very specific. It's a set of ordered pairs in which no two ordered pairs have the same first element or independent variable and different second elements or their dependent variable. And a quicker way of saying that is the same x value cannot have different y values. So if we're talking about points, the same x value cannot have different y values. So again, if I had points, for example, I'm going to use the same point 1, 2, but if I have a point that is also like 1, 3, this would not represent a function because I have the same x value, but I have different y values. So this would not be a function. Alright, be sure you have those examples written, and then we're going to show you the three kinds of ways you're going to see functions. You're going to see functions on a table, you're going to see functions in a graph, and you're going to see functions represented as an equation. So again, in algebra, an information such as a function can be represented in many ways. This would include a graph, in a table or data set, so again a list of points, or just a table, a little more organized, or with an equation. So I'm going to start actually with the equation, and I'm going to work kind of forwards, and these are all going to represent the same exact function. So I'm going to start with this one. With an equation, multiply the input by 2 and then subtract 1 to get the output. So these terms we've probably heard before. Input and output, again, just means what goes in a function and then what comes out of a function. So if I put a number in the function, I don't know what the number is going to be, but then I will get another number out. So both of these are actually going to be variables. And typically when we talk about input and output, we're talking about our variables x and our variable y. So I'm going to call the input x and our output is going to be y, and typically that's how you will see things. You will see the input as x and usually the output is y. Okay, so multiply the input by 2, then subtract 1 to get the output. Alright, so there you have it. Now I'm going to move into, again, now I'm going to give you some values, again, so we can graph them. You know that tables and graphs are highly related to each other, same as equations. I put an equation in my calculator, I could get a graph, I could look at the table. So if I put this into my calculator, I will get some output. If I put 0 in for x, I will get -1. If I put 1 in for x, 1 times 2 minus 1, I will get 1. If I put 2 in for x, 2 times 2 is 4, minus 1 is 3, I'll get that. And my last one, if I put 3 in, 2 times 3 is 6, minus 1 would be 5. So I have a table. Now I can actually graph these. I'm going to use a little thicker of a point just so you guys can see it a little bit better. So 0, -1, 1 and up 1, 2 and up 3, and 3 and up 5. 1, 2, 3, 4, 5. Alright, take a moment, make sure your setup matches my setup. I'm just going to shrink my pen back down. And so what we're going to do down here is we're going to take some notes just about how I can see or determine if something is a function. If a graph is a function, we will say that it will pass the vertical line test. What that means is I can draw vertical lines on this graph and it will never hit more than 1 point. So again, I'm going to just sketch really quickly what we have here. Right on my graph right now I have these points, and if I connect them I would have a line that looks like this. Terrible. Not straight line, my apologies. And what I'm saying with the vertical line test, again I'm going to change to like red, is no matter where I draw a vertical line, it will only hit in 1 point. Only hits 1 point at a time. And that would pass the vertical line test. If I have a graph and I draw a vertical line and somewhere on that graph I can draw a vertical line and it hits 2 points, then it is not a function. And we will look at some examples in class. Okay, on a data set or in a table, again just like our example when we defined the word function, is we're looking for no repeating x values, and if there is a repeating x value, there cannot have different y's. Okay, so here I'm looking, there are no x's that are repeating, right? There's only 1 0 in this column, there's only 1 1, there's only 1 2, there's only 1 3. But, and I'm just going to kind of sketch this in real quick, if I had, let's say, another box to this, right, and I put a 1 in here, and all of a sudden, now 1 maps with 2, well, that's a problem. I have repeating x values and different y's. That would make it not a function. So again, that's what I'm looking for. I'm looking for no repeating x's, and if they are repeating, they can't have different y values. And our last one, when I'm given an equation and I do not know what this looks like, you should graph it. And remember, you can only graph it as long as it's solved for y. And if it's not solved for y, then you have to make sure you write it as solved for y. You can solve using our literal equation, right, steps, and move everything around so that it says y equals, and then I can put it in my calculator and you can graph it. If you graph it again, we're going to go back to, does it pass the vertical line test? As long as it does that, then it is a function. Hope you have all these notes copied. Looking forward to seeing you in class and discussing more about functions and looking at some more examples.